So today let us start with this numerical of finding resultant of a non-concurrent coplanar force system. So in this what we need to do is we need to replace the system of forces and couples by a single force and locate the point on the x and y through which the line of action of the resultant is going to pass. So these are non-concurrent force systems. We have some direct forces, we have concentrated moments, or we can also call them as coupled moments or coupled forces. We need to find the resultant, and wherever that resultant will locate, we need to find the location on x-axis and y-axis. Okay, now everything is given directly except this theta. So this theta we need to find. This theta we can find like this is the opposite and this is the adjacent. So opposite is 4 meters. If you see 2 plus 2, 4, and this is 3 plus 2, 5 meters. So we can find theta is tan inverse of 4 by 5, which will be equal to 38.6598 degrees. Once we have found theta, let us select point O as reference point about which we may find the moment of all forces. So if you remember in the last lecture, how we found the resultant of a non-concurrent force system is that we took a point and then we translated all the forces to that one point. We made the non-concurrent force system to a concurrent force system, and then we found out the resultant, right? So let that point on this force system be this point O. So we will be basically translating all our forces and moments to this point, but we will not do it directly. Like there are steps that needs to be followed. If you follow those steps, then you will automatically translate all the forces. But we need to simplify also everything. We cannot like always keep on bringing all the forces to one point. We need to simplify our procedure. Right, we need to keep one procedure such that it remains in the minds of students. So what we are doing is, part A is to find the resultant force. Okay, so first we will be finding a resultant force directly by doing summation fx square, under root of summation fx square and summation fy square. Right, so this is a formula that we'll be using directly to find the resultant force. And you will see that the net horizontal force summation fx, to find this net horizontal force, we actually do not require to bring all of them to a single point, because the net effect of this horizontal force, even if you bring it to this point, it's going to remain the same. The net effect of this, the net vertical effect of this force, even if you bring it to this point, it's going to remain the same, right? So let us not bring them right now. Let us first find the resultant and then we will find the moment. So we first need the summation fx, net horizontal force, and let us move like this. Let us take this 20 Newton first. So it is minus 20 and my sign convention will remain the same, that is x in the right direction is positive, y in the upward direction or upward force is positive, rightward force is positive, and anti-clockwise moment positive. Okay, so minus 20 is the first force. Then do we have any other horizontal force here? This is a vertical force, this is a moment. We have the 6 Newton which we need to resolve. So when we resolve it, it's going to have one component in the right direction, one component in the upward direction, right? So that right component or horizontal component will be 6 cos theta, and that is positive. So plus 6 cos 38.6598. I get summation fx to be minus 15.3148 newtons. Therefore, it means that it is acting in the left direction. Alright. Next, we need to find summation Fy. So net vertical forces, we have this as a vertical force, it is acting upwards. Summation Fy, we have plus 12, and then this is a moment we have directly this force 6 Newton, and the upward component is 6 sine theta. So plus 6 sine 38.6598. I get Fy as 15.7482 newtons. So it is acting upwards, right? Now I have my Fx and Fy components. Fx is acting in the left direction. So let us say that my particle is starting from this point, it is reaching here, and then from this point it has to go upwards and it reaches this. So this is the start point, this is the end point of my particle. From start to end we join an arrow. This is my resultant. So the resultant has to be oriented like this, in this manner, in this direction. Okay, and the value of the resultant will be 21.9669 newtons, and the angle of the resultant alpha will be tan inverse of 15.7482 divided by 15.3148, which is equal to 45.8 degrees. So my resultant is acting this way and it is inclined at 45.8 degrees. Part B is to find the summation of moment due to all forces about point O. Okay, now we are finding the summation of moments of all the forces at point O. So if you do these two steps, that is, first you find the resultant and then you find the summation of moments, basically you are indirectly just translating all the forces and all the moments at point O. Okay, for the simplification we have these two parts separate. We are not doing them together because it will be a lot of confusion. Therefore we have it as part A, where we only find the resultant due to forces, and part B, where we only find the moments due to forces. So summation M, let us start with this 20 Newton. So 20 Newton is acting at a distance of 2 meters and it will be going anti-clockwise about point O. So I pin this point and let that be center of rotation for all the forces. So this 20 Newton will go anti-clockwise. Therefore we have positive 20 into 2. Then this 35 Newton meter is there. We know that for a moment we do not have to multiply it by the distance. Moment is independent of the distance at which it is acting. So we can directly take the sign of the moment, which is plus 35. Then we have this 12 Newton, which is acting like this is the line of action of 12. So the perpendicular distance from point O to its line of action is 3 meters, right? And this 12 Newton will go anti-clockwise about point O. So it's positive, plus 12 into 3. Then we have this 15 Newton meter, which is again an anti-clockwise, so it is plus 15. Then we have this 20 Newton meter, which is clockwise, so it will be directly minus 20. And then we have the 6 Newton force. Now you see that this point O is lying on the line of action of 6 newtons. So we understand that this 6 Newton is not going to cause any contribution into the moment, correct? So even if you take its resolved components, you will understand that you just have to multiply the resolved components by 0. So at the end the moment due to 6 Newton is 0 basically. So we get summation M as 106 Newton meter. We get a positive value, it means that it is an anti-clockwise moment, right? So now we have both part A and part B with us. Part A, we have the resultant as 21.9669 newtons acting at 45.8 degrees, and we have moment of 106 Newton meter. So this entire system we can represent as a force of as a resultant of 29.9669 acting at point A at an angle of 45.8 degrees, and we have a moment of 106 Newton meter, right? So this is one type of depiction of your resultant, that is, you depict the entire force system as a force and a moment. But let us say that I want to depict this only as a force, right? I don't want that moment, so I have to take care of the moment by shifting my resultant to a certain distance. Now to get an anti-clockwise rotation, this resultant, you have two options. Either you can shift this resultant to the left of O or to the right of O. but you need to determine that shifting to which side is going to give you your anti-clockwise rotation. So the answer is that if you shift it to the right side, only and only then you are going to get an anti-clockwise rotation. Okay. So you can write this as, by Varignon's theorem, we can say that R into D is equal to summation M. So D or basically 21.9669 into D is 106. So D I can get as 4.8254 meters. Okay. So now I can shift this resultant at a perpendicular distance of 4.8254 from point O, and this is going to have the same rotational effect of 106 Newton meters at point O. What is asked in the question is that at what points on x-axis and y-axis does the resultant cut? So basically what it is asking is to find this distance and to find this distance where it is cutting the x and y-axis. Okay, so if we give these 2 points, we can say that from these 2 points my resultant can act. Correct? So how to find them? This is x and this is y coordinate. In this triangle, in this right angle triangle, we just have to use our trigonometry. So this is 4.8254 here, and we have a right angle triangle and one angle we know. So we can use sine theta is opposite upon your hypotenuse, right? So like sine of 45.8 will be 4.8254 divided by x. So x will be 4.8254 divided by sine 45.8. So x I get is 6.7308 meters, and y will be if this is 45.8, we understand that, or now if you have got x, you can find this y like using tan formula also, or alternatively what you can do is, if this is 45.8, we can find this angle, and then using the cosine formula, cosine or sine formula, we can always find this y. So y can be also given as 4.8254 upon cos 45.8, right? Because if this is 45.8, we can say that this also has to be 45.8 degrees. So it's all about just how you are comfortable in trigonometry. So we get y as 6.9215 meters. Okay, so this completes our problem by finding the resultant of a non-concurrent coplanar force system and locating the points at which it intersects with your x and y axis. Okay, so that's it for this lecture. Till then, take care. Thank you.